Here in this video, we're going to look at solving systems of equations by using the elimination method. The elimination method is basically you're trying to get your system of equations where you have the same coefficients in front of one of your variables, either x's and y's, and you're going to wind up lining the two equations up, and then you're going to add and subtract their two equations to eliminate a variable. Now, these problems that we have here in this video, they start off requiring the least amount of work, and as we work our way towards the last example, they're going to be the most involved, where you have the most number of steps. Now, as a guideline, in order to solve a system, you're going to write the equations where the variables are in the same order, and you write them on top of each other. And then you're going to have to determine which variable is going to be the easiest to eliminate. Sometimes you'll have to manipulate the equations by multiplying one or both of the equations by a number. So that way, if we add the equations together, a variable is going to be eliminated. And you could technically, you don't always have to add, you could subtract, but through adding or subtracting, we're going to eliminate a variable. That allows us to solve for x or y, and then we're going to plug that in and solve for the other variable. So that's kind of our steps. So let's look here at this first problem. I want to solve this system by using the elimination method. So what I'm going to do is I'm going to write the two equations on top of one another. So we have 4x minus 5y is equal to 46. And then we have the second equation. I'll just change colors. The second equation is negative 4x minus 4y is equal to 8. And so when I'm looking at the two equations, I'm trying to get the coefficients to match in front of a variable. Where if I look, I have a coefficient of 4 in front of this x in the blue equation, and a coefficient of negative 4 in front of the x of this greenish equation. So what you have to do is you got to figure out, well, what operation do I need to do to get those two variables to cancel because they have the same numbers? Well, 4 plus negative 4 makes 0, so I would choose addition. So I'm going to add the two systems. Now when I add them, I'm going to add top to bottom. And so 4x plus negative 4x makes 0x. And then we would go negative 5y plus negative 4y, which is going to give me negative 9y, is equal to 46 plus 8 makes 54. All right, well, 0x is just 0. So I have negative 9y is equal to 54. And then we would solve for y. So notice how we only had one variable left. I'm going to divide by negative 9. And that's going to give me y is equal to negative 6. So negative 6 is the value of y that solves this system. Well, what you do from here is you pick one of your two equations to plug that into. It does not matter which equation you use. Whichever one you think may be the easiest. And I'm just going to pick the first equation that I wrote. There's really no wrong equation to pick here. So I'm going to say 4x minus 5, but I'm not going to write y because where y is, I have to put the y value that we just got, a negative 6. And then we're going to solve this for x. So we have 4x plus 30 is equal to 46. And we're going to minus 30 from both sides. That gives us 4x is equal to 16. And then we would divide both sides by 4. That gives us x is equal to positive 4. So x is 4 and y is negative 6. Solves the system. Now I'm just going to write it as a coordinate data point that relates x to y. So 4 comma negative 6 solves the system. Okay, new problem here. We want to solve the system via the elimination method. We have x minus 10y is equal to 18 and negative 6x minus 10y is equal to 32. Well, I'm going to write the two equations on top of one another. So I have x minus 10y is equal to 18. And then I have my second equation, which will be green, negative 6x minus 10y is equal to 32. And I try to figure out how to proceed here. Now, I'm looking, and I have in front of the y's this exact same numbers. I have negative 10 and negative 10. I can make those 10s cancel out if I subtract. because they're the exact same number with the exact same sign. So what I'm going to do is I'm going to subtract the two systems, top minus bottom. So I'll have 1x minus negative 6x. That gives me positive 7x. And then we have negative 10 minus negative 10 for my y. So we end up with 0 y's, which is supposed to happen because they're going to eliminate. And then we have 18 minus 32. So 18 minus 32 gives me negative 14. And then we continue to solve. All right, well, 0y is just 0. So I have 7x is equal to negative 14. And then we're going to divide both sides by 7. And that gives us x is equal to negative 2. So there's the x value that will solve the system. Well, from here, go pick the easiest looking equation to plug in for x, so that way you can solve for y, and it does not matter. I'm going to pick the first equation. And so simply, I'm going to start writing it, but where I see x, I don't write x, I write its value. So I'm just going to open a parenthesis and write the rest of the equation, and I'm going to put negative 2 in where that x was supposed to go. And then we're going to evaluate for and solve for y. So we have negative 2 minus 10y is equal to 18. And then I'm going to add 2. And we have negative 10y is equal to 20. Divide by negative 10. And that gives us y is equal to negative 2. So negative 2 is the value for y that'll solve the system. Now, the system of equations has a solution where those x and y values happen at the same time. So it's at negative 2 by negative 2. All right, next problem here to solve by using the elimination method. So we'll go ahead and we'll write the two equations on top of each other. So I'll take the first equation, which would be 4x plus 5y is equal to 13. And then I'm going to change colors and write my second equation as 8x plus 7y is equal to 11. And we'll look here, and what we'll notice is none of my variables have the same numbers. My y has a 5, my y has a 7, x has an 8, and this x has a 4. So what I need to do is I'm going to have to adjust one of my two equations so that way they'll have the same coefficient in front of one of the variables. Well, the easiest variables to make the numbers match in front would be x, because simply I can make the 4 become an 8 like the green equation just by multiplying it by 2. So what I'm going to do is I'm going to multiply my top equation by 2, and then I'm going to rewrite it. So I'm going to times that top equation by 2, and that's going to make me have 8x plus 10y is equal to 26. And then I'm going to write my second equation just like it was, and I'm not going to change it at all. So I have 8x plus 7y is equal to 11. Now that the numbers match for the x's, we're going to solve this system. Well, I can make the x's eliminate if I do 8 minus 8. So I'm going to choose subtraction for my system of equations here. And then I'm going to start subtracting. So 8x minus 8x makes 0x. 10x minus 7y makes positive 3y. And then equals 26 minus 11 makes 15. And so we would solve that. We end up with just 3y is equal to 15. Divide both sides by 3. And we have y is equal to positive 5. So 5 for y will solve the system. Now what you have to do is you got to get the x value. So I'm going to go pick an equation to put 5 in, and I'm just going to use, it doesn't matter if you use the first equation, the second one, the red one or the green one. I'm going to use the 8x plus 7y is equal to 11 equation. And so I'm going to start writing it. 8x plus 7, but instead of y, we're going to input the value of y that we just got when we eliminated the x variable. So I'm going to put in 5. And then we're going to solve this and get the corresponding y. So we have 8x plus 35 is equal to 11. And then we solve for x. So I'd subtract 35 to the other side. And we do that where we have 8x is equal to 11 minus 35 is going to be negative 24. And then we're going to divide by 8. And that's going to give us x is equal to -3. So when x is -3, that's a solution to the system. But I need to have the x and the y happen at the same time. So the system of equations is solved when x is -3 and y is equal to 5 at the same time. Okay, last example here. This is going to be the one that requires the most amount of work to use the elimination method. And so I'm going to let the first equation be red and the second equation be blue. And I'm just going to go ahead and write them on top of each other so I can see what I'm working with. So 4x minus 5y is equal to -6. And then I'll just let green be the second equation. -6x plus 7y is equal to 12. Now, I look at the two equations, and I have 5y and 7y, 4x and 6x. So it's going to be very difficult to just multiply one equation and to make a variable match. And so in this instance, what you're actually going to have to do is we're going to have to multiply both equations and get a common factor, so that way I can get the equations to become the same. So if I pick the variable to cancel, I'm going to pick the x's. So I want to try to make the x numbers become the same. And I'm going to say, all right, I'm going to choose to get the x's to eliminate, which means there's a common factor of 12 when you're thinking about 4 and 6. So I could, if I multiply the top equation by 3 and the bottom equation by 2, I'll at least have 12s in front of my x's, and then we would rewrite. So my red equation, that top equation, would become 12x minus 15y is equal to -18. My green equation, so I choose to multiply by 2 so I can get a 12 in front of the x and have -12x. And it's all right that the signs are different. They don't have to match exactly. Plus 14y is equal to +24. Now that I have the same number in front of the x, even though they're different signs, it's okay. I'm going to solve this system. Now I can make the x's cancel out and have a 0 in front if I do 12 plus -12. So I'm going to choose to add this time. So I'm going to add the top line to the bottom line. 12 plus -12x gives me 0 x's. -15y plus +14y gives me -1y is equal to -18 plus 24 is going to give me 6. And then so we have -y is equal to 6. We would divide both sides by -1, and we get y is equal to -6. So -6 for y will solve the system. I just got to get the corresponding x value. Does not matter what equation we pick. I'm going to pick the original first equation here. And so my red equation. And I'm going to start writing it. So 4x minus 5. But since we know what y is, I don't write y. I'm going to open a parenthesis. And then where that parenthesis was, we're going to put the y value that we got when we solve. So the y value of -6. And then now we just continue to solve for x. So I'd multiply -5 times -6 makes +30. And then we would subtract the 30. And we have 4x is equal to -36. Divide by 4. And we wind up getting x is equal to -9. So -9 will solve the system. Now, the actual answer to our system combines that x with the y. So it'd be the coordinate -9 by -6. There's our answer using elimination where we had to multiply both equations.